On the other shoe, when you're going from meters to larger distances, decameters, hectometers, kilometers, you are going to be dividing by 10. And the same is true no matter where you start. So I'm going to use black here for this one. If I have, like, let's say, for example, 5 kilometers, if I have 5 kilometers and I want to know how many centimeters that is, well, I would see that it goes 1, 2, 3, 4, 5. I would have to times it by 10 5 times in total to do that. So this is just a chart we're going to be using quite a bit here. Just erase some of that stuff. Right, so when you move left, it's growing by 10 for each space. Elsewise, it's divide. So let's go through some of this stuff here. So again, if I have 65 kilometers, well, I can see that 65 kilometers to meters, 1, 2, and 3. It's being times by 10 3 times, right? You don't need to draw this on your actual chart. I'm just doing it as like a visual representation. So if I have this first one here, right, 65 kilometers to turn that into meters, all I take is that 65 and I'm timesing it by 10. Oops, by 10 3 times, and I get, yeah, 65,000 meters, right? But the same is true the opposite way. When I'm going from meters to kilometers, when I'm going from left to right, it is dividing by 10 each time. So now I'm taking that 1200 and I'm going to divide it by 10 3 times, because that's how many spaces it has to go. And I can see that, oh, well, 1200 kilometers is actually only, or sorry, 1200 meters is only 1.2 kilometers. So I'm going to give you guys just like 30, I'll give you 1 minute. I'll give you 1 minute, try out question C, D, and E using this table up here. I'll quickly power through those answers.
Decimeter, you would just times it by 10.
Yeah, so if you're going from decimeters, DM, to meters, it would be, if you're moving to the right, it would be divided by 10.
Oh, okay.
Yeah. Yeah, really pay attention to the acronyms here. DM versus DAM. This decimeter, decameter, those are really easy to mix up. So yeah, for this first one, if I'm dividing this by 10, I know that that's going to give me 40 meters.
Would you be able to just go off first?
Oh, yeah. So just these other ones from millimeters to HM, which is hectometers. You go up 1, 2, 3, 4, 5. So you have to times this by 10 5 times. Or if you know like how your decimal points work as well, you can move that 5 times. But either way, if you don't, your calculator can do the heavy work for you. But this would give you 0.056 hectometers. And then all the way the other way. So you have, what is that, 98 billion? 98 billion millimeters to kilometers. So you're going up once, twice, 3, 4, 5, and 6 times. So you're dividing that by 6. 4, 5, 6, 7, 8, 9. Divided by 10 6 times, or I could just 1, 0, 1, 2, 3, 4, 5, 6. Again, if you don't, you can always just do the low in your calculator, but that's going to give you 98,000 kilometers here. And like I said, you can always just choose to move that decimal for every 10 too. 3, 4, 5, 6. It's whatever you prefer. There's many, many methods. So, keep it on down here. What I'm gonna have you guys do here is I'm gonna have you guys try out these first 2 questions here. This is just a review. We're just practicing this stuff. This is kind of a skill we're gonna be needing because we're gonna be working with specifically distances here. You know, so I'm confident you guys should be able to try this out. If not, like, let me know. Please ask for help if you're not sure. Now, if you're looking at this table here, basically what you're given is you're given 3 different units of measurement, and you have to convert that for every single one here. So let's just using this first one here, for example. Well, if I have 280 decameters, and if I'm moving to do hectometers and kilometers, I'm moving to the right. Well, I divide it by 10 each time, right? So this would give me here 28, for example. This would give me here 2.8. The other way around, if I'm going to the left, I'm going from decameters to meters or decimeters, you're multiplying it by 10 each time, right? So I'll give you just a minute to fill out these 2 questions here. Like I said, if you're not sure, ask for help. This is just a review of some skills that we need. This is not actually what the unit's about. But just quickly powering through this. This is not the main skill. It's just kind of something we need. 0.003255. Just quickly, 178.5. Okay. So yeah, so one of them is, we need to be able to understand, we need to be able to convert units is really the main goal here. So that's an important skill, is all of that is converting units. Now, the other skill we need before we can keep going is, I'll leave that up there in case people are writing. We need to be able to round numbers down, or up. We need to be able to properly round numbers. So this entire topic deals all about accuracy. This is something that's used a lot in engineering, manufacturing, construction, any trades whatsoever is a really important skill. So we need to be able to convert units, and we need to be able to round them very well. Let's say, for example, we wanted to round up, this, I have 87.253 millimeters to the nearest 10th of a unit. Now you might be wondering, well, what's a 10th of a unit? In this, a lot of people are like, oh, a 10th of a unit, that'd be this 2. Well, no, it's actually this 5 here. In fact, I'm just going to highlight that. So when I say, hey, I want us to round it to the nearest 10th of a unit, that means to 2 decimal places. So how I actually do that, how I round things is, oh, I see, I've left this in here accidentally. I've left an example here for question A. But you can see here what I've done is I have I know it's the nearest 10th of a unit, that's this 5. So the first thing I'm doing is I'm identifying what point is that. It's that 5, it's the one with a little underline there. So basically I then look to the number that's to the right of that, right? Which means I'm looking at the 3. If the 3 is between 0 and 4, I'm going to round this number down, which means I would get 87.25. Because technically there's a 0 here, right? I'm saying, hey, this 3 is going to turn into a 0. But we don't write that. We're lazy. We delete it. So it actually goes to 87.25. But let's say, for example, that this 3 was, let's say it was a 6. It's 5 or greater. If it's 5 to 9, that number's going to get rounded up. So that would turn it to 87.260. And again, we're lazy. We don't write that little 0 there. It would be 26. In this case here, this number is just going to give you 87.3. Because wait, what? Oh, right. Sorry. I'm looking at my tenths. That's this one. Everyone has that. So the order that it kind of goes in here, we're just going to write that up here. So the order our numbers go in. So I'm going to go 0.1, 2, and 3, for example, right? So 0.1, 2, 3. In this case, the 1 would be our tenths, the 2 would be our hundredths, and the 3 would be our thousandths. So this is what we use. We shouldn't really have to go any deeper than that. That should be all we know. But so this is the one thing where the rounding is quite important.
So the first number would be a 1, and then the second one is 10, and then the third one is 100, right? Like, so 2 would be 1, and then 5 would be 10ths, right?
2. Oh, you're looking at this one.
Yeah.
So the 2 would be the 10th in this case. So I'm looking at the number to the right of it. Sorry, that's why I meant to highlight there. So I gave you guys a bad explanation, and that's my bad. But yeah, so the first decimal place is our 10th, the second is our 100th, and then the third is our 1000th.
Oh, okay.
Yeah. So let's go through here then. So if we want to look at the number to the nearest 10, we're going to look at the number to the right of the 10's position. So I'm going to use question B here, right? So 3,564 meters to the nearest 10th. I'm just going to write that in here. 3,564 meters. So the first thing I always do here is I'm going to identify, you can write this if you want to. I'm going to identify the correct unit. I'm going to figure out which one is the actual 10 in this case. Now, you notice there's no decimal place here, right? So I didn't say 10th, TH. I said tens, S. And that, if that's the case, it would be, I'll highlight it. I care about this spot here, right? The 6 is my tens position. So then I'm going to look at the number to the right of that, which is my 4. It's between 0 and 4, so it's going to round down. So basically, I'm going to get 3,560 meters. That's rounded to the nearest tens. There's a difference between the TH and the Z and the S at the end of it. For question C, it wants me to convert, I'll just rewrite it, 42.3979 centimeter to the nearest 10th and nearest 100th. You don't have to write this down if you don't want to, but I'm just doing it so I don't have to scroll back up and down, up and down, up and down. So just like before, the first thing I'm going to do is I'm going to identify the correct position. In this case, I'm going to start with the 10th part of it. If I'm doing the 10th, I can see it as a TH. That means the part I care about then is going to be this 0.3, right? So next I'm going to look at the number that's to the very right of it. It's a 9. If it's a 9, it's going to round up. So for the tenths, I would now get 42. It technically be like 32.39, and then I need to add on 1 here, right? Well, that's actually going to give me 40 or 0.4. Now, a lot of people would be, okay, it's 42.4. Because I need to round this 9 up, which gives me a 10, which is where that why that 3 turns into a 4. But this is not correct. It says to the tens, even if there is a 0 in that position, you put it there. Because it's specifically asking for the tens. If it did not ask for the tens, you could actually get rid of that 0 entirely. But because it's asking for the tenths, I need to put that 0 there. And then also the other way around is, well, what about the hundreds? If I'm looking at that, if I'm identifying which one of those that is, well, that is going to give me, that's this 9 here, right? So then I look at the number to the right of that, which is the 7. The 7's obviously higher, so I'm going to round it up. So that's going to give 42.398 centimeters. Like I said, rounding down is quite important. It's usually going to be millimeters, centimeters, meters, and kilometers. But you will occasionally see those other ones. So rounding up and down and converting are our 2 skills here we really need before we can really start diving a little bit deeper into the other stuff. So just like before, I got 5 questions down below. I'm going to give you a couple minutes. So I got 3 questions down below. I'm going to give you a couple minutes to try out these 3 questions here. I just want you guys to round them to the appropriate place. Again, if you're not sure, please ask. Really, really important because we need this skill because we're actually going to start learning the new stuff here right away. So I'll give you, I don't know, like 4 or 5 minutes to go through these questions as quick as you can. So again, if you're rounding down to the nearest 10th, TH, that is going to be the first point after the decimal place. So I'll just do the first one there as an example. Around to nearest tenth, I look at the 7. I can see it's, you know, it's 5 or higher, so it's going to be 567.2. Sorry, 0.3, because it rounds up. Meters. So you guys like another 2 minutes or so. Yeah, if you're looking at 100th of a unit, you're looking at the second decimal point afterwards. This first one here would be 92.79 centimeters. Give you 30 more seconds. And then to the nearest whole unit is I'm just looking at, you know, I'm looking at this part, right? So I'm going to look at the number that's to the right of it, which is basically the first decimal point, the 7 here. And it's going to round up to 2,988 kilometers. So I won't go through all of them there. If you have any questions on any of them, let me know. And
For
mhm.
number 3D, what would you put?
Oh, for number 3D, so that's a good one there, right? Because it's the 0. So if I'm doing nearest 10th of the unit, this is the unit I need to either keep it the same or round up. So look at to the right of it, it's a 5. So this would still give me a 0.1 kilometer.
Oh, okay.
Yeah.
0.6. 0.06.
No, it wouldn't be 0.06 because I only can round up to the nearest 10th. So anything after that doesn't exist after I round it. So let's go in then and start learning some of our new stuff. So where we're really focusing with today is we're looking at something called accuracy and precision. Those are our two really big goals here today. So accuracy is when we're measuring how close a measured value is to its true value. We're measuring how accurate something is. Specifically, what this basically means is that we are using, it's looking at the types of measurements. So actually refers to the exactness of the measurement, or rather, a measured value must be as close to the value as possible. You might be wondering, what the heck does that mean? Again, a lot of math is converting math to actual plain old Jane English. That's what we really want to do here. So let's think everyone here should be at a table, right? I'm going to assume most people are on a table or something right now. So let's try this out. So I'm going to go to an example. Let's turn this into English. Let's build some context to this. So I just want to load up a picture. Okay, so if I give you like a little kitchen table here, you know, how would you choose to measure this? Would you choose meters, kilometers, or centimeters to show how long it is?
Well, probably centimeters.
Probably centimeters, right? You'd probably look at this. Well, this table is 150 centimeters long. Maybe you go 1.5 meters, but most people would probably say, hey, probably centimeters, right? But yeah, or inches, right? You use a small unit of measurement to try and accurately give it. But like I'm using centimeters specifically for this. Let's say you do centimeters, 150 centimeters. Well, technically, maybe the table itself is slightly longer than that, just by like a little hair. Maybe it's 150.5 centimeters. Maybe there's that little extra bit. Maybe then if you zoom in even further, maybe it's that little extra bit. So there's a real length of this table, which is going to be like lots of decimal places long. 150.5273 centimeters. But we don't speak like that in real language, right? So what would we say? Yeah, the table's 150 centimeters. So when I say real value, the real value is that super precise one. But the measured value is the easier one to grasp our head on. We don't go in there, we don't zoom in on it until we get to the smallest possible decimal point we can. We just use plain old common sense. The table is 150 centimeters. So if we're looking at these measurements here, so if we're looking at the following measurements and we want to give an accurate measure and the measuring device, well, what would we do? So for the first one here, if I'm using the length of your forearm to measure the length of a picnic table, I know that sounds kind of weird, right? What do you mean using my forearm? Is this going to be, first off, is this going to be accurate for question A? No, it's not going to be accurate, right? We all have different sized forearms. We have different lengths of forearms. So like way back in the day, they used to take, I forget what it was called, but basically they would have the king stretch out his arms like an eagle. They'd measure how long that is. And yet you get a king's arm worth of cloth. So every time you get a new king, you have to do that Newton measurement again. It's not a very accurate measurement, right? Additionally, so everyone has different lengths of forearms. Well, what if I say, hey, I want half a forearm of picnic table. I want 3.5 forearms of picnic tables. You're guessing where the half is, right? So it cannot be divided into smaller units. So we're just on page 81. So you're using your forearm for a picnic table, very inaccurate, right? The next one here, though, is, well, what if I'm using the length of your stride? That's how far you walk to mark off the playing field for soccer. I'm sure everyone here's done that. If anyone here's ever played like football, you take a couple steps back, you use your own feet as a measurement. But this would not be, if you're using the length of your stride, how far you walk for each step to try and figure off how big a field should be. Not accurate, right? How come? How come that's an inaccurate measurement?
Striding varies. Different people.
Stride length varies. What if I have really long legs? What if what if the other person's 5 feet tall and has really short legs? Really short stride. Not very accurate, right? You can use it to estimate. You could probably come fairly close, but it's still not that accurate. What if I use a meter stick to figure out the distance between two cities? So my first question here is it going to be accurate?
Yeah.
It would be accurate. Absolutely. You'd know down to the meter how far it is from Regina to Saskatoon. But does it make sense? It doesn't really make sense to do a meter stick per time to actually get the real distance, right? There's a real distance between Saskatoon to Regina, but we don't have people going out with a meter stick and putting them back to back to back. So it would be accurate. Because it's a standard measuring device. This is something all across the board. Your stride length, your forearms, those differ from person to person. The meter stick that I have in my classroom is going to be the same as the meter stick in every other classroom, right? It's a standard measuring device. So yes, it's accurate, but it is not an appropriate measuring device. So you can have something that's accurate, but that isn't very appropriate. And finally, what if I'm using a ruler that has marked in millimeters to measure the width of a book? So using a ruler with millimeter markings,
Yeah, it will be accurate.
that'd be, it's just, millimeters, right? It would be accurate. Absolutely. Millimeters are accurate. It's a standard measuring device. And now the second question comes. Well, isn't it an appropriate measuring device?
Yes.
Yeah, it's appropriate measuring device. How come? That's the hard part.
This is standard.
It's an appropriate scale, right? Like it's a fairly decent unit to use with it. There's a reason we use kilometers to measure distances. Even from one part of the world all the way across to the other one, we know what a kilometer is. It's an appropriate scale. So we're looking for, is it accurate or not? Is it an appropriate measuring device, and how come? We'll leave that there for just a second. Now, there's 3 more questions down below. I'm just going to give you guys a second to go through them. If you're not sure, just guess for now. We'll quickly power through those, but that's what accuracy is. So there's 3 questions. Was it 6, 7, and 8? I'll give you guys about 3 or 4 minutes here. Try out questions 6, 7, and 8. If you're not sure, just guess. Right? This is an opportunity to kind of practice this stuff to change how we think a little bit. So question 6, 7, and 8 here. Try these 3 out I'll give you 3 minutes or so.
Give you a couple minutes here, try out question 9, 10, and 11. So let's get up and running. So we're gonna do I think we'll do 2 more examples here and then we'll get up and running. So This first one here. So we have a pretty good understanding of what precision and what accuracy and what uncertainty and accuracy, all this stuff is, right? So we can identify those things. Now we're going to be applying it to things.
So basically, if we have someone who's mixing juice in a jug and it's in quarter liters, she measures the amount of the juice in the jug to be 2.5 liters. What we want to know is we want to know the measurement of the juice in this form. This is that thing that we boxed way up above. This is a standard way that we write stuff. And we're going to want to know the range of the volume in liters. So, so we need the uncertainty, we need the value, but how do I find uncertainty again? How do I find what uncertainty is?
Half the precision.
Half the precision. So you're saying, you're talking about the 0.5 here. So we're close. So we know that uncertainty, and I'm just going to write this here for a note. You don't have to, but uncertainty is 1/2 of the precision, right? So what's the precision?
2.5.
So, well, that's the measurement, but is that what the precision is?
Would be 1 liter.
So the jug itself is marked in quarter liters. So it's in quarter liters. So our precision, I'm going to say is P, would be 0.25 liters, right? Because that's what a quarter is, right? So reading the question is quite important here, and like trying to really understand what it means. Where most people are going to make a mistake with this is they'll think, oh, it's 0.1, or oh, it's, you know, it's 1, or, but in this case, we're looking at how is it marked? How is it measured? What unit of measurement is being done? Normally we look at, like, you know, the centimeter on rulers and stuff like that. But the precision is the tool of the measuring device. This jug has a measuring device built into it, which is in quarter liters. If you guys might see those in jugs or pots you have. But so now I know what the precision is, and with that, I can figure out my uncertainty. So let's answer this question in the form it wants us to do. What's my measured value here? How much juice is in the jug?
0.25.
Well, the amount of juice in the jug is 2.5 liters, right? So it's 2.5 liters of juices in the jug. But it wants it in the form of, this is our measured value, 2.5 liters plus or minus our measurement uncertainty. What's my uncertainty again? Half my precision. So I would take half of 0.25, which would give me 0.125, yes, liters. Okay. So when we write the measurement of something, this is the format we always use. And I think this is given to you. I'm pretty sure this is given to you, but let me confirm that. No, that is no. Okay. So this is something you need to have memorized by the end of this. Again, but you can just think about it. What's the measurement and then half of the precision. So that is not something you will be given directly on your formula sheet. They might give this to you on your final. I will need to go back and look again. Just so you know, your final exam is going to be multiple choice as well. So that'll probably help jog your memory there as well. But anyways, so that's the measurement. Now, the next thing it asks us is, what is the range of volumes? So if you remember with our lovely little clock, I don't have it up there anymore, but with my digital clock here, this goes up to minutes, right? But this could be 12 minutes, and there could be like up to 59 seconds in there, right? There's a range that this could be. We know there's second that still time passes on. So if I'm looking at this juice here, well, what's my range? I'm saying that, hey, how much juice is in this jug? Well, I'm saying there's anywhere from 2.5 liters plus or minus this. So how do I figure this out? I'm literally going to plus or minus this. So what we're going to do is we're going to add and subtract that uncertainty. So let's find the lower range. Let's find the minimum amount. There has to be at least this much juice in there. I know I have 2.5 liters. And I also know that there could be this much less liters, 0.125 fewer liters in there. So there has to be at least 2.375 liters in the jug, if that makes sense. Because I know that, because I think there's 2.5 in there. I don't know for sure because I have some uncertainty. I have a range of errors in there. The 0.125 liters. That's what we've identified, that, you know, that's what your uncertainty area is. So how would I figure out my maximum then?
You just add.
Just gonna add it, yeah. I know there's I think there's 2.5 liters in there, but I could be as many as 0.125 liters off. So if I add that up, I'm gonna get 2.6125 liters. So this is the fancy way of saying is that there could be between 2.375 liters and 2.625 liters of juice. Now, no one ever likes writing out a full sentence answer. What most people would do is they just put 2.375 liters to 2.625 liters. So most people are just going to do that. So you're looking at a range of things. So just like before, you got 3 questions here down below. I'm going to give you I'll give you 6 minutes, 2 minutes per question here to try out question 12, 13, and 14. And again, if you're not sure, please ask for help. But I'll give you about 6 minutes here. Try out question 12, 13, and 14.